Okay, well, welcome to lesson 1.2. We're recording from Mabton, Washington. How about that? In the Yakima Valley. Okay. All right. So let's see. So we're going to learn about parabolas again, but we're going to learn another way that we can graph them. And there's another way we can write these equations, and you might be amused by this, I hope. And so let's get started. So graph quadratic functions. That's what we've been doing in section 1.1 as well. And we're going to learn another way to do it. We're going to learn another way. So our objective today, students will be able to write the quadratic function in vertex form. Vertex form is going to be convenient because it makes the graph really easy to do. And so to graph a quadratic function, what is the advantage of writing it in vertex form? Well, that's what we're going to find out. That's our essential question today, to figure out why is that helpful. So here's the deal. What we've been doing so far is writing the quadratic in standard form. So let me show you what that means. Don't worry. Oh, here we go. So what we've been doing so far is we've been writing all these equations like ax squared plus like bx plus c. That's what we've been doing, right? And we found out that when we have the equation written this way, which this form here is called standard form, okay, well, we found out a little secret about this. We found the vertex by taking the x coordinate. We go, it's equal to negative b over 2a. And that allowed us to find the vertex. But you know what? If we have the parabola written in this form, we can get the vertex because it's sitting right here and right here. We have the coordinates already. So you don't even have to do this calculation over here. And remember, this only gave us the x coordinate. And after we got the x coordinate, we had to find out the y coordinate by plugging it all back in up here to find out what the y coordinate was. So that took a while. It took at least a minute, right? Well, like I said, again, what's nice about the vertex form is that the vertex is sitting right here. These two coordinates are it. And so it's going to be really kind of cool. I'm going to show you how this works. What happens is the parabola, remember, we have what's called a parent function. The parent function starts off at the origin, okay? But what we're going to do now in this setup right here is we translate the parabola and we vertically translate it. So now what we might do is we translate it this way a certain distance, and that distance is going to be called h for horizontal, right? And then v for vertical. Actually, we use k for the vertical direction. And so then we might lift it up after that a new spot right here, so that the parabola then might be sitting here instead. Does that make sense? So you like translate it this way, you go over vertical, horizontal. Alright, that's the idea behind the setup right here. Okay? Now, this h will be the horizontal shift, the k will be the vertical shift. Now, in practice, this is actually quite easier than it looks. Okay? So let me demonstrate with an example now. Okay, so here's an example. We can find the vertex very quickly. Alright, there's just one little tricky step, I think. Okay, the vertex. And this is a trick that's going to be repeated throughout the course. Okay? There's other times where this trick will come up. We want the x and y coordinate, right? The x coordinate is sort of sitting right here, almost. Okay? Now here's the thing though, it's not positive 2. It turns out it's negative 2. Okay? I'm going to put a negative 2 here. Alright? And now this one is the y coordinate. Exactly as it's written. You see? It's positive 5. Now, let me show you how you can find this out without making a mistake here. It's kind of tricky. A lot of people say, well, why isn't it positive 2? I thought you said it was h and k. Well, let's go back and take a close look at that. When you looked at it, it had a negative sitting here, right? On our problem, we have positive sitting there. So it's actually not written in the correct form. Let me point that out real quick. On the previous slide, it said y is equal to sum a times x minus h squared plus k. That's what it said on the previous slide. You see, that's not a minus there, is it? You see? Well, this all looks confusing, but there's a really easy way to deal with it. Okay, let me show you a little trick I learned a long time ago. The fastest way to figure out the h here and the k, you want to figure out this coordinate right here, right? It's just the opposite of whatever that sign is. It's going to be negative 2, but here's what you do. Hang on. Commercial break. Mr. Russell. Yeah, I tried to do that. I'll try accumulating time. Okay, so there's a really fast way to do this, and I'll show you how to do it. Okay, here's a little trick. You just take this part that's in parentheses and you set it equal to 0. X plus 2 is equal to 0. The part that's inside the parentheses, set it equal to 0. And now solve for x. Minus 2, minus 2. You get x is equal to negative 2. You see? And so now I know that this is a negative 2. Now the k is always easy. It's exactly what's there. So it's 5. Okay?
So the negative one also doesn't matter at all?
It will in just a minute. We'll explain what the negative does. But right now I'm just looking for the vertex. Well, so the amazing thing is, on the graph of this thingy, I have the vertex is at negative 2, 1, 2, 1, 2, 3, 4, 5. So the vertex is sitting right here. There's my vertex. Okay. Well, that was quick. I mean, most of you guys will see that you can find out the vertex within 3 or 4 seconds. I mean, in practice. It only takes about 3 seconds to get the vertex. When the quadratic formula or the quadratic equation is written this way, to graph the parabola, I can get the vertex really fast because the coordinates are sitting right here. Well, here's the thing to remember. Whatever's written here, just remember it's always going to be the opposite. If that's a positive 2, you put negative 2 here. If you have a negative 2, it's going to put positive 2. That makes sense? Now it's only for the part that's inside the parentheses. Okay? The other number is sitting right here. Okay, so there's our vertex. Now, by the way, does this open up or down?
Down.
Down, because again, this part here is what tells you whether it opens up or down. This thingy opens down. Alright? So how am I going to graph the graph, though? I know it goes down, but does it go down fast or does it go down kind of slow? Remember, this is your axis of symmetry. There's an axis of symmetry that's passing through right here. I know this thing opens down. So why not just find another point and then use its mirror image? Well, I might use 0. Okay, so check it out. Let's use Noel's advice. He says, why not try 0? I'm just making some room here. At x equals 0, what do we get? Well, in this case, we get y is equal to negative 1/4 0 plus 2 is what? 2. So that's going to be 2 squared plus 5, right? But 2 squared is 4. So this is equal to negative 1/4 times 4 plus 5. Well, 1/4 of 4 is actually negative 1 plus 5, which finally equals 4. Alright, that took a little bit of work, and I showed a bunch of steps there. But anyhow, when x is equal to 0, y is equal to 4. So that means there's a point sitting right here. Is that right? And that means also 2 units to the left. Remember, this is 2 units from the axis of symmetry. There has to be another point right here. So this parabola kind of opens up kind of shallowly. Kind of like that. There you have it. I find the vertex and one other point, use the mirror image, and I'm done. Is that faster? It might be a little bit faster than that other method, right? Yeah? Before we get started, you should see another one of these, right? Make sure we get it down. Alright. Okay, so we did that. We did all these steps here. We found the vertex. The vertex was negative 2, 5. So we're up here. 1, 2, 3, 4, 5. 2. When we plugged in x equal to 0, we ended up getting positive 4, I think. So we're right there. And so we had another mirror image point over there. And so our parabola did that. There's an axis of symmetry right here. And so here's the thing. When they're asking you for the vertex, okay, you should write it down in your problem somewhere. We found out it was negative 2, 5. We drew in the axis of symmetry. That's this spot right here. And the axis of symmetry was x is equal to negative 2. You're going to have to start doing that on some of these problems here, where they ask you, well, what is the axis of symmetry? Okay. Alright. Well, so let's move on. Let's try another one. Okay, so the vertex, let me get my graph on there. There's a graph on there. Okay. The vertex is easy, right? Hopefully you'll be able to do this within 3 seconds. Remember the trick? It's whatever this is, but the opposite. So it's positive 3. And this one is exactly what's there. Minus 5. Bam! I have the vertex already. Isn't that cool? You have to admit, that's a little bit cool. After doing what we did last night on the assignment, I mean, we had to do x is equal to negative b over 2a. And it wasn't that terribly hard, but it did take a few seconds. And then we had to find the y coordinate and plug it all back in. That always took at least a minute, right? Well, now it only takes 3 seconds. So everyone knows where the vertex is. It's at positive 3, negative 5. There it is. I already have the vertex. And consequently, I already have the axis of symmetry, right? The axis of symmetry has to pass through the vertex. So I like to dash it in. Now if you have colored pens, that's really cool like I do. Makes your graph looks really cool. By the way, does this open up or down? Opens up this time, right? Because that's a positive number. If you're A, this is our A now. Our A is sitting right there. If that's a positive number, it opens up. Well, so now what's a good choice to get my second point? Anyone have an idea? Pick a point that's nearby, right? But not too close. I wouldn't choose 2 or 4 because it's too close. Why not go with 0 again? 0 is not bad. I like that. So let's choose x equal to 0. Okay, so if I choose x equal to 0, then I get y is equal to 1/2 times 0 minus 3 squared minus 5. Now, this might lead to an ugly fraction, but you can do fractions in your calculator, right? Hopefully that doesn't cause too much of a problem. This is going to be 1/2 times negative 3 squared minus 5. Now, I don't know how good you are with fractions, but that's going to give you positive 9, right? So this is going to give you 9/2 minus 5. And again, I don't know how good you are with fractions, but 9/2 is actually 4.5. Right? Those are your cooks. You do half cups. If you do 9 half cups, you get 4.5. Right? That's equal to negative 1/2. Or equal to negative 0.5. Well, so the point is, if I were to plot that point now, and when x is equal to 0, I get y is equal to negative 1/2. So I'm going to think that's right there. Does that make sense? Can I go up? Is it too low? Is that better? Okay, so I know there is a mirror image point on the other side of my axis of symmetry, and I went over 3 units that way, so if I go over 3 units this way, it has to be like over here, right? There has to be another point sitting right here. And so I know when my parabola does this, bam, turns around, starts coming up. You see how much faster it is to graph these guys now?
Yeah.
A little bit faster. That's the advantage of having the quadratic equation written in vertex form. So one of the goals later on in the chapter is to take your quadratic equation, do some algebraic manipulations to it so that it's in vertex form. Don't you want to learn how to do that?
Yeah.
Oh, sure. That's lots of fun, right? Sure, why not? Alright, well here's an application problem. Let's take a look here. It says the Tacoma Narrows Bridge in Washington, it's in Tacoma, has 2 towers. Oh, the towers rise 307 feet. Okay. Above the roadway and are connected by a suspension cable. There's this cable that comes across like this, and those cables are connected to the road right here, and so there's a lot of weight on this cable and it's holding up that bridge. Okay, alright, so they're saying where x and y are measured in feet. What is the distance between the 2 towers? What is this distance? Well, if we're clever, we know that there's a vertex sitting right here, right? That's the minimum, right? If we can find out the vertex, I know that that's the halfway spot, right? And then I know you go an additional halfway going that way, right? Because there's an axis of symmetry here. So why don't we just find out the vertex? And if I can find out, remember the vertex has an x and y coordinate, right? And remember, if I have the equation written in vertex form, I can find out. It's right here, isn't it? It's, yeah, change the sign though, right? So it's 1400, right? And then the y coordinate is 27. So if you go over this way 1400 and you go up 27 right there, that's where the vertex is. So how far is it all the way across? It's another 1400, right? And so the total distance across here is 2800. Here you had an application problem and didn't realize how easy it is, right? So it's 2800 feet. How easy was that? You guys were afraid of that at first, huh? Oh my goodness, application problems are tough. Turned out to be pretty easy. All right, so we'll stop right here, and we'll come back and finish this up tomorrow, and then you'll have most of the period tomorrow working on the assignment. And so I'll give you the study guide tomorrow, and we'll start the book assignment tomorrow. I think you can realize this assignment's a little bit easier, right?